Alright, in the last video of this unit, we're going to talk about conservation of momentum in inelastic collisions. So in the last video, we talked about elastic collisions, and in elastic collisions, perfectly elastic collisions, kinetic energy is conserved. In inelastic collisions, objects are typically sticking together rather than bouncing off one another. And momentum is conserved, of course, it always is. And the kinetic energy is not conserved. Kinetic energy is not conserved. Okay, so let's just do a simple example. We'll use conservation of momentum first, and then we'll look at the difference in kinetic energy before and after the collision. So let's use an example of the cars again. So we have one car, and let's say that it's going at a speed of, let's say it's 2 kilograms, I'll just keep using that as an example, and it's going this direction at a velocity of, I don't know, 3.7 meters per second. And over here we have another car, and let's say it's 1.6 kilograms, and it's going in this direction at 1.3 meters per second. Now, eventually, this car is going to run into this car and catch up with it. Now, let's say that when it does this, that the cars then stick together and they are going to move off in one direction as a unit. So once they collide with one another, they're stuck together and they're going to head off in this direction with some velocity v. So this is the before and this is the after. So let's figure out what the velocity or the final velocity of the cars is after they run into each other. So just like all the other problems, we're going to say all the before stuff here has to be equal to all the after stuff here. So the momentum of both of the cars at the beginning has to be equal to the momentum of the system at the end. So I'm going to have the mass times velocity of the first car is 3.7 times 2 mass velocity. And we're going to add that to 1.6 times 1.3. Okay? And they're both going to the right, so we'll just make that the positive direction. Now, once they have hooked together, now they're moving as one thing. So you've got the 2 kilogram car and you've got the 1.6 kilogram car. So instead of having two momentums over here, we actually only have one momentum because they're stuck together and now they're just one object of a certain mass moving away. So the total mass over here is 3.6. And then I would solve for the final velocity. Okay, so now how you might see this equation written, which looks like sort of a big mess, would be like this. Okay, but again, that looks like a big complicated equation, but really we're just saying all the momentum of the stuff at the beginning has to equal all the momentum of the stuff at the end. So let's go ahead and punch that in and see what we get for our final velocity. So 3.7 times 2 plus 1.6 times 1.3 gives me 9.48 equals 3.6 v, so we'll divide by 3.6. So I get my final velocity of the cars together is 2.63 meters per second. Now, we said in an inelastic collision that kinetic energy is not conserved. So some of the kinetic energy is lost, and typically this happens because of when two things collide and they stick together, there's some sort of heat given off, there is friction, there is a loud noise, so there's all this energy leaving the system. So let's go ahead and figure out how much kinetic energy was lost during this collision. And in order to do that, all we need to do is figure out, okay, the before the scenario and the after the scenario. They're not going to be equal to one another, but if we have the before and the after, we can figure out what the difference is, and that would be how much had left the system. So the kinetic energy before, we're going to have 1/2 mv squared plus 1/2 mv squared, right? Sorry, that doesn't look like a v. is not equal to the 1/2 mv squared at the end. So let's just plug in those numbers and see what we'll calculate what we get here and what we get here, and then take the difference. So 1/2, the mass is 2 times 3.7 squared, plus 1/2, the mass here was 1.6 times 1.3 squared, is not going to be equal to 1/2 the mass, again, it would be the mass of the whole system because the whole thing's moving, 3.6, and then the final velocity we got was 2.63 squared. So over here we've got, so that's just 1, so 3.7 squared, and then we get 0.5 times 1.6 times 1.3 squared. We'll add that to 13.69. On the left-hand side, I get about 15.04 joules. So I'm running out of room here. Let me just write below. So here I get 15.04 joules. And I know that's not going to be equal to what I have at the end here. So at the end, I've got 0.5 times 3.6 times 2.63 squared. So there, I only had 12.45 joules. So what is the kinetic energy that has been lost? Well, I would just take 15.04 and I would subtract 12.45 that the cars at the end have, and that would give me how much energy has left the system in the form of like light or sound or heat or what, friction. So it would be 2.59 joules lost. Okay? So we can figure out joules that are lost. We can also use this to show that it is an inelastic collision or a collision that's not perfectly elastic. All right, so that's conservation of momentum in inelastic collisions.